Okay, hello everyone. Good morning, good afternoon. As promised, I continue to have these videos. And before that, before we jump into calculations or estimations, let's wrap up what we did. Not wrap up, maybe let's see what is the result of what we did before. So we are finally get the data here in these formations or in these folders, and it will give you eventually the geojsons, OGC, just Open Geospatial Consortium's format. But then before that, before we jump into the analysis, I did some changes here. So what I changed here, I try to make this as more scalable, but maybe not optimized yet in some software engineer, if you know the codes. But yeah, this is what the approach that I want to do here, that I did. So instead of using the hard-coded everywhere here, so I put in a variable. So then if you want to change some information, please change here. Not this one, but yeah, the hard-coded here. I would say maybe input, and then here put, and then here is input. Okay, so then I change here. Maybe I will show you later about the differences, but in a nutshell, I put the approach not use the HTML scraping anymore, but with this JSON. And then from this JSON, you can uncomment this and then just comment the rest of the codes if you want. Then you will get the result of this yield data like the first approach that what we did before. But then don't forget to deactivate here the pipeline. Somehow it's also gave you the error in the data. So in order to make understandable, to make you understand about the flow, just please comment this for the rest of the codes, and then just do some yield in the example of JSON, let's say. And here we put some example of the JSON. Now we use the JSON API as the response. For instance, if we go to here, I don't know, random API here, if we go click JSONs, we actually get the JSON. So this JSON is, we can directly get this regardless the Scrapy, but what we have with Scrapy now here is because the process is already streamlined, and one of the package design of Scrapy here is very interesting. So they have already the the package, work package, or some classes and object and methods that already cover with how they request the data for downloading and how the response will be handled in this pipeline, let's say. So everything is already covered in Scrapy. That is very, I'd say, very beneficial or a good advantage for scraping especially. But now we only use AVI though, but let's see later about the result here. Now we are downloading the data like usual, like previously, but the difference, of course, now the approach here, everything is using the JSON. Again, we take the response JSON here, not to get the response.txt, but get response JSON. Maybe if you remember, first we use this very specific to a scraping method, but now we only get this JSON, or maybe let's say convert the JSON into a dictionary object here in the service list. And then yeah, again we use the metadata technique here, put the metadata of the response so that the callbacks will get the access to the previous variables. And we get the metadata gets again with this same again, and then yeah, it will like directly processing into the following callbacks. And until then, what makes difference here again is not only putting everything on the JSON. Maybe I will ensure that you also look at the JSON here. If we go to this JSON here we previously take the data based on the Scrapy HTML method with the XPath, but now we take this JSON and then we will get this JSON. And then we let's say do some iterations for loop, and then we take only this object and then this type, and then we rearrange the URL, let's say with this wait a second, bro. Here, and then the type server. So we will get to this, and then we again take another, oh, what's going on here, guys? Okay, something's wrong with token. I don't know why. I hope that's not happening, but not. I think because we get the result right here. It's not like we are forgetting the token, but here we again take another approach with putting this API get method, I'd say, and give the parameter here with the f equal to p JSON or pretty JSON, I would say. And then again we take this as a layers, and most importantly this ID, and then we replace again the I would say parameters and get these numbers instead. Now we get these things again, and then we click again with the JSON, and let's see, we put the parameter in, and you remove the parameter again later, and then let's say with this query, and now you got the query. And then here this part we only, again I will remind you that we only take the object ID numbers. So we take the object ID list here you can see why we put this -1, because in ArcGIS, as far as I understand, that will take you every data. Or maybe you can go with this query. I think it will also work, this one. But yeah, what we need here is just to get this geometry and overlay the data and get the IDs only on the specific AOI. So we're not extracting all in Indonesia, because that will take time here, because now we only optimize the API based on per request per object ID, so it will take time. Okay, I will post in the GitHub. That's the whole point, I think, to make you more understand on how we structure the code here, and we'll save here. And then again is request per ID here. It's still the same approach, and then we put in the send item. Yeah, again I almost forget here what we did that makes difference as well. Here we're not putting the geojson object, maybe I would say, opposed to geojson You see format is no longer used because I intentionally only focus on polygon before. But then if the data, let's say the input of geometry is not polygon or is not rings, that it will give you too much work, okay, to do some let's say conditional and more and things that like that. So what I did here, I just append this data, and first thing first, what I also did here, okay, so I going back again to this one, creating the data frame design. And the data frame design, it has the features. So the format of the let's say the time series here, it will have something like this. I will format the document, guys, just too bad. Okay, so the format by the default, it will have something like this. So I export first, I observe in the ESRI. After I export the feature to JSON, and it will give you this format. So I just elaborate in this format. This is based on the JSON as well, API JSON, so it won't be the mistake will be a minimum as possible, and we just append the feature based on the JSON per ID. So yeah, that's it. I think I hope it's covered first, and then let's see what's going on here. Oh, it's still doing it. Okay, let's try to open QGIS now. Previously it's not responding, so I will create a new empty project here, and then let's go with our previous result. This one is previous result. I just changed the name here. So what we have here right now, we get this data, and in its data we get its informations, while the differences here is not appear in QGIS because it's only saying that it's used the let's say geojson here. But if we go here and look at the structure in the previous let's say, oh, not this one, yeah, this one, you can go that this has the structure of the open OGC standard of geojson, sorry. But then if we want to look at what is the usual data, or the maybe let's say, oh, is this for Indonesia? Oh no, that's one for the ESRI format. Then let's go with JSON to feature first. This is just for example, guys. What we have now, it's Dev 2017. Okay, just close this first maybe. Let's try with the, yeah, this one. Okay, it works. Now if we going back and then we go with feature to JSON, which means this will be a ESRI JSON, and let's go with maybe the I will go with this example, let's say. Okay, let's go guys, and I will put to the side. Now it's very different here, right? And we get this 5 rename field aliases, and then we get this fields and alias as well. Aliases is for, I don't know what this one for, but they have this based on the data here. Okay, so this one is the format, and it's also aligned with the ArcGIS server API. So it is a good idea that we follow the ArcGIS API instead of geojson directly, and we already know that geojson somehow is long to, it takes time to load. So let's wait for the process here. And so we are looking for here the process that is finished now. So we are going to check what is the result. So you can either actually, for the first, you should know that everything here is the same on the maybe let's say this is the least least chunk, like this one. This will have a chunk at least that has at least I think 100 in the chunk, and it will merge into this one JSON. So this one is pretty much a list, and then this will be merged here in the JSON, let's say. But let's look at the what we did now with this merging all these lists into the JSON, and this particularly this is the geojson. Specifically this is geojson with the ESRI geojson format. So does it work? So let's see, and we open the folders. No, this already provided here. And then let's go, hey, not this one, this. Okay, it works guys. So yeah, I think I said something about geojson OGC is not work in QGIS, but it seems that I was wrong. So here geojson is work in is let's say ESRI format. geojson works in QGIS as well, and here is the geojson that it's from ArcGIS format. That's actually is the same structure, almost the same. What we don't have is like a shape here. We don't need, maybe just an addition to what we learned before. Let's go with the case when we have this script. But here in this script we are currently like doing a for loop of all these data here. So all the data here will be extracted no matter what in the script, in that script particularly. But what if we want only to have one data at specific layers, let's say? If you are going to do so, then maybe let's go with the example of using two data at the same time. Let's say what I'm talking about here. I will visualize, or not visualize, I will put some example just to make it clear. Okay, this one, observations. Okay, I will use this as the example, and then let's go with this and copy paste with the new approach. Let's say this one is SICAP zone observations. So I will have these numbers. Okay, here we change the name, just conventional name. We can just say this one whatever we want to name it, but the most important is here SICAP zone conservation, let's say. And then the allow domains, maybe I would go with this same the same domain that is the origins, and then we will go with this approach. And let's say this one is output JSON locker. Maybe I will have example as a parent folder, and then we put another folder. So yeah, it's this is it depends on your favor, on your custom folder that you want, custom locations that you want. But here let's go with the approach first, and then let's go with to take all. Oh yeah, I forgot this one, to take all the data. And okay, so here the layer name is already here. This layer name, I meant, is will be follow the layer ID, and let's see if it works. Okay, and then we need to check as well here the bbox as the same bounding box that we are agree on. So I will put here again. Okay, so as the input, so here is the input, and also this link suffix and base URL as well as the input. So you might need to change it later for a specific layer, one layer, and now it's become like two layers at the same time. And we have the bbox locations that will be stored as well, or will be as an input, not stored, will be in become an input. And we also do this like same approach, similar approach, and we go with the folders. Folder conventions name is in the output JSON local again in here, and we will get the folders name like this if we have two layers. And we of course we not use this bbox, we will bbox as the JSON. So with open location JSON bbox JSON.load. So this one we also can change this manually, but at the moment let's do this step. Okay, let's go again, bro. Let's see what's going to happen here. Okay, this one is from the parameters that we have. You can also go with the developer tools and then make sure it's the same, the input. So developer tools is here. Maybe I will show you quickly. Like this one. Yeah, if you, so you will have these payloads, and you can go with this and copy, paste, and change this into string, and it becomes something like this. So those will be parameters. Okay, notice that the parameters is in the string. Everything is in string except the integer or the EPSG ID. Okay, but anyway, it will also be encoded by the URL, I think, URL encoded, and it becomes a parameters. And after the question mark, and it's this, all of this data is a parameters. So it is a get method, the API, and it will give you the list of the object ID's name, and also we will get this later on the structure. In first, again, I already covered at the previous here in the previous codes. I already said that this is the exact the same approach now with the JSON, but here with the data frame design. Okay, so here is the code. You can read in the videos. I will share later the codes in the GitHub if the viewers is already enough. And here is the code. And also the important is in the pipeline here. Pipeline, you go with this, you can skip this part because we don't use that approach anymore. We're creating a class like the first video that I said, and we close the spider. When spider is closed, we are like collecting all the data from the Python object, and we also take the chunk size, splitting the chunk size into 100 per 100 IDs, I mean feature, and then we use it this approach. We read the data that it is for a data structure, and then we append the feature to the data structure, and we finally redump again the object into the data that we read before. I don't know, should we close first and then we open again? I don't know, but it's what I have right now. So you can skip this part because it's comment, but this one is not comment. And the setting, don't forget, use this some pipelines, and then use this as your Scrapy parent folder name. Okay, that's all. I think that's from previous code, by the way, previous video. Please look at the previous first videos of this list. We're going to look at this. Okay, so guys, that's okay. So after we run the software, let's say, or the script, so it's not like give you the expected result, because I still not handle if the area of interest doesn't have any object ID. So this is the result of, where is that? I just closed it. Did I close it? This one. So here is the result. So it say that the object ID is null. That basically means that in these areas or in this AOI there are no is not contain anything about this zone block conservation, let's say. So maybe let's go with another approach. Let's go with the exact let's enlarge the AOI basically. So basically this need to be troubleshoot somehow if object ID is null, let's say. So we just keep the output in empty result then, instead of give you the error. but let's cover that later. Now let's go with this bbox for a Papua island, let's say, and let's crawl on this island. Oh, but first I think maybe we should close this up now. Okay, later. Let's go. Oh wait, let's close this up. Let's delete this again. I meant. Okay. Whew. If no bug, then it's not coded. Okay, if there's a bug, then we learn from the bugs or the mistake, then we are somehow improving the skills of how we find the solutions. Yeah, that's how it is, I think, to add your headache. Okay, let's wait. So let you leave this or no, I don't. Searching. Oh, let's go. It's done. This is the geojson of it works. So let's go in here and where is that? I need to refresh, and then okay, this is the layer number 0 basically, and it's layer number 1, and it's loading. Okay, so the zone is here already now. It's this funny shape, but yeah, that's the zone based on the GIS analysis. That's pretty cool. This data. And what is about this zone? Let's confirm it with this XYZ tile OpenStreetMap. Okay, it's loading. Oh no, this one is marine and what else? That's not marine, I think one is national park and one is national park. Let's go with the metadata. This all is time series. Previous approach, but here is this zona. Okay. Block kawasan konservasi or conservation areas block, and this is zoning of national park. So the number 1 is national park. Here is the national park. Why on earth national park is in here? Oh, okay. So national park include marine. So cool. And here is the conservation zone, which protected zone maybe. Okay, that's cool then. Alright, we are going to take a different approach, not just directly consume all this or take all the data from the deforestation, but we are going to use this exact data of the land cover. So PL is penggunaan lahan, again land cover, and from the land cover, if the deforestation definition is if it change from forest to non-forest, then it become a deforestation. Okay, that's very straightforward. I know the definitions can be varied. Every definitions and institutions, but let's keep that in this simple fashions, that it is about the conversion or change from forest to non-forest, whether it's permanent or not, like maybe it generates someday. But let's say this is deforestation, it's one time at the first year, so let's use that approach first. I mean, the first year is first time deforestation, that will be deforestation. But let's see in the script whether I will implement that or not. Okay, now maybe let's do some automations with doing this. Let's say we are going to clip all the JSON into exact OI. Where is the OI? I forgot. I think I didn't put in the... Oh, what's happened? Okay. So here the actual AOI is in the envelope. This one is not the actual AOI because we wrap this up into... Oh, it's not up here. Oh, it seems doesn't work. Oh, not this one. Too much AOI, bro. Yeah, this one. Okay, so the actual AOI is in this feature envelope. So let's export this feature first to the geojson for analysis in QGIS. Okay. Box. Okay. Now maybe we can save. Oh yeah, by the way, this is a new approach that we are going to use QGIS for the process analysis. As we can see that here, this is the result of downloaded land cover, let's say, from ArcGIS server. But then because it is not clip in specific AOI, it will be like spatial joint, and we need to clip all of those areas that is only overlap with this bounding box, let's say. It can be either in some other AOI like boundary of administrations, district, sub-district, and so on, but I will choose to use this simple rectangle as well, since I requested the areas at the beginning using the AOI. So what we are going to do is to use this QGIS called as QGIS Python or Python QGIS. By first thing first, we need to activate here the environment for QGIS. So you can search into Google's or browse internet how to activate the environment and make things work in QGIS that can be installed in Conda, let's say. But this environment still, it's also part of the environment from ESRI ArcGIS Pro. I intend to use this as an integrated library in ArcGIS Pro, but it seems that it doesn't work. So I need to make this separate, let's say separate environment. So if you see that here, environment that I have now, we have a base environment that is activated by default, which means that this is not included ArcGIS. But here ArcGIS Pro, that is default basic or default let's say library from ArcGIS Pro that we should not alter or install pip in here, but instead we clone this into MRV. I previously tried to clone this with the QGIS environment, let's say, but I failed to do so because it has a conflicted library between QGIS and ArcGIS Pro. So I just created another environment using conda instead, but not cloning from ArcGIS Pro. So having said that, I can conda install QGIS, and we can run the terminal after QGIS activated, let's say. And if we also install Jupyter Lab, because I like Jupyter, and we can have a more interactive interface with the codings. So I run also Jupyter Lab or Jupyter Node in this case, and here we can run QGIS Python here. So let's maybe start from beginning again, or start from the start of the beginning. So here we are trying to import system, import OS, and also import GIS as well, QGIS as a main library, and we will run these applications. And please look at this. This is a different things that we can use at different OS also has different plugins to say that it's installed in QGIS, so we need to make sure that everything is installed and can be run through this plugin system. So please look at this in planet like Jupyter and so on. Look at the QGIS, and what we are going to do is first we need the applications, and we run the processing application, because mostly we are going to run the process or processing, or this one is like geoprocessing tools. So when it's done, it will tell you if the tools that is installed properly or not. Here, get this result. I think it works. And now what we are going to do here, we want to let's say looking for the data from these locations, which is relative locations from this path output JSON local, because our notebooks is in here. This is our notebooks, and dot min is our current locations by relative positions. And here we go to the output JSON local, and we go to the time series. Now we are going to walk. Library names walk. So it means that we are going to search the directory part and directory names and file name as well. What walk has, actually it can go to the subfolders. Previously I have the case where I have the data inside of my let's say my folders, and it's a archive. So I don't want the work OS is running into layer 2, let's say. So I don't want that happens, so it will break. So it's just only one layer min here. So layer that's not layer file layers, but layers of folders. So here we are going to filter as usual, like before in ArcPy, I think, for the naming system. But here we filter with the if conditional filter. So if we get the file inside of the path, and also in this file we have JSON. So what we are interested right now, what our concern is to get these files. Whatever files that has underscore geojson.json, it will come in. as a part of the analysis, or it will append it these files list. Okay, to be clear, I will run this to make sure it runs properly, and then here is the result. So everything here of the process of work, it will go to inside these folders and look at the other folder, and so on until all of those folders is iterated. So if we found geojson, it will append it here in the files. If we found folders, it will append a new path, or it's equivalent to the text name, I guess, your name. Forgot. Yeah. So here is the files, and of course we need the files name only, not only the path, because here is the path. It's the file JSON is new path with the path as well. But yeah, we can do it either here in this process, or we can do another list. What is this name? List? What is this kind of list? So if we go this, and we will got only the file names. So why would we want to go get these file names? Because at the end we are going to change this let's say naming conventions here, and change with the something like clip. So okay, so I will comment this, and here we change the naming with this we replace the geojson with the empty string, which means erasing it, and we will add another with this _clip.json. So it will clip with the OI. So basically this one is like a file names for the output. So that's the file names new, and then we'll go this result. So we will have this at the end of the day as the result. And to make sure it will give you the folders, or it will save in the correct folders, so we will still use the relative path here. I don't know, I hope it works later on in the for loops, but later this one is folders, and we will join OS join with these new file names later on. So let's skip this part now for the moment, and we are going to use the OI for clipping. So clipping here, I actually did some trial first. So what I did is not like rememorizing the codes, because it's just too long to memorize this one. But what we can do here, we can just go to processing toolbox here, and then go to the history, and then here is the history, and then you copy as Python command here. And once you've done that, you can just go back here, and then let's see and investigate the pattern that we have. So process input, it's called native clip, which means for clipping, and here is the input key, and you can make it pretty like this, and well, you get this at the end. Ultimately you have this 3 key that you need to fill in, and this one we should take this as the output should be reflect with our process here. Let's say the os.path.join folder, which means these folders, but with this I for loop, which means the index of this, and then we get this folder is based on the indexes obviously, and we will join with the file names new, like what we are planning to do, the output of this file names. So basically it will give you another file names in here, each of the for loops in the index. And here the input of the file, of course, it also based on this one. So that's how it for loop with ei and range and length. So yeah, you don't need to memorize the codes again. You can just know the step that you need the most, and what is the objective of your code is. So let's start, and maybe to make it more interactive, and so then we can track our result. Let's print something here. Okay, so we tell them to print something that also reflect on the input, let's say. So we are processing the files. Or maybe we can go like this. Okay. And next. Okay, just this is a simple dummy, but let's go and see what happens first. I think maybe relative path will give you an error, but let's see what happened. Defined folder is for, oh, it doesn't work like that way. Basic, bro. Okay, now we got an error here. That's the problem with QGIS, bro. You got to fix invalid feature first. Okay, let's fix this first. Gosh. Okay, this only happened in QGIS. I don't know why. Just example, and so then we can get the starting to be headache. Copy the Python command. Let's go with this. Let's say maybe before this, paste this codes and make this pretty as possible again. Okay, that's more straightforward here. So I will take this. I would say the output is, I don't know if we can get this directly or not, but not file names new, but it's, oh my gosh. So we have this, and then we need to replace. I know it sounds stupid, but might work. We are just replace what we did, and we will add the name again. Let's say fix geom JSON. Will it work? I don't know. So let's go with this again. Copy this one, make them as input. Okay. It makes sense at the first, but I don't know what will happen after. Okay, let's go. Oh, .geojson. .json. Oh my god, what's that? The input should be no. So you don't need to add this one though. But yeah, okay. Just did. Okay. We are processing now. Whew. Okay, so it said it's already done with the 90s and it's already fixed the geometries. Let's go, what's happening now? First things, let's clip. Boom. Okay, it's so much smooth. Look at this, so smooth. Okay, here it's done with this, and then after this, all of this done, and we might need to go and going back with the ArcGIS, because I think we want this in a GDB format first, and what we concern is we can just go with this PL first. Okay, then we can compare later with this def. PL is land cover, and this is deforestation, and we can focus on the PL first later on, so then we can analyze ourselves land cover change. Okay, so it's still processing, so till this finish we'll come back. Okay, everything is finished here. It's done already. So let's check maybe whether at this recent land cover. You don't need to check it one by one, by the way. Let's see one of this. If there is an error, that it will come up as it will pop up. I think it will like not continuing the codes. I didn't put try and accept formula, so yeah, might not happen. So we done with the QGIS first now, because we will move forward again with the ArcPy. Here I just don't want to export the data first to JSON, everything into JSON in the ArcGIS, so why not use this directly in the QGIS for clipping. But since it's not as a pleasant Jupyter Notebook integrated in software GIS software like ArcGIS Pro, so I will use ArcGIS Pro because it's directly connected. So yeah, it's depend on your personal options whether you keep with the QGIS or not, but yeah, for my approach I will use this now. Okay, so let's come back again with this ArcPy, say, or ArcGIS Pro. Let's go with the catalog again, and let's just make maybe to make it same approach, we can go, I think I already have this I will copy this first. Let's go with this path. Have this as well. Okay, let's work with ArcPy again, guys. So to make this larger. And the workspace, we need to, here it's the differences with Jupyter Notebook that's running in terminal versus this one. We need to specifically use the absolute path, not with the relative paths anymore, because I don't know, maybe the process is not running in specific the terminal. Maybe let's say if we put the terminals, then it's, if we run the terminal here, Jupyter Notebook run in this terminal and it has the path, then it will relative, or the root folders, it will be based on this path. But for this case with the Jupyter Notebooks inside ArcPy, we don't know where this Jupyter Notebooks running. I think it maybe is in Windows system, but yeah, my point is just use absolute path in here. So how do we do that? So it's easy, pretty easy. You can just go like this. So let's say this one is, I want to make this not a workspace, maybe you can call it a workspace, but let's try another folder or new, or maybe this one. Oh my gosh, where am I? This is it. Okay, just go with this, set the workspace. Let's do workspace, there is none. We don't need to have this. Cut paste there, output. Okay, the dear output, it will go to this output just on local, since we have this excluded in Git. So I just want to put in here, and then new geodatabase, and let's see, maybe time_series gdb. Copy this path again, and let's become output gdb. Press paste in here. So there is no dir inside of the workspace, but if we go with the paste dir output, and let's see what we'll have. No, we don't need this yet. I know. Okay, should be, where is that? Oh, just type it by yourself. I think. Okay, yeah. So the file name will be reflected with the same name as this folder name. So let's go with this approach. We will go that the base dir output is let's make it from the start. File gdb, maybe not this one. Doesn't make sense to say it. Did we import OS? Okay, it's done. What base dir output comma f or f in list file names, yeah. Did I? Some mistake may be happening. Okay, it's done. So it will store everything in this time series folder. Where is that? Yeah, it will store here. Everything is here without making a dataset or feature dataset, but each feature class will be sent in this gdb as the name of folders. So here maybe this one is from the previous all files, path file. Okay, now we will go to the files. Workspace here, time series, join time series is, we have the list file names. This file name is the workspace, the full workspace. So it's only the folders. Since we know the pattern now, we can just go with the existing pattern that we have. Oh no, please, it's gone. Anyway, I will do it manually here without looking at this and expect that it works. So the file base dir output not, oh dang, why is this, you don't take all of those, notepad file. By the way, workspace in there, so go with the folders. Folder plus folder, folder plus folder. Can I use os join with the tree path? It works. Oh no, too much. Okay. File. Okay. Now here is the files that we have. So it makes sense. Right? Okay. Let's see what happened at the end. Fix geo not clip on geoson. Okay. All right, it's cool. Now do it just the same like what we did before. Yeah, I just put it simple here because what we have right now is polygon, so make sure maybe let's comment this. Let's see what's going to happen here. All file okay, that makes sense. And the input JSON is all file, and all path output it should be output gdb I. Okay, just let's go. I need something else. It's the naming. Gosh. Big impatience as always. Okay. Now it seems works. It will takes more time in the land cover because it's bigger, obviously, but it's faster than QGIS, of course. So you pay for it, right? Almost done here. Can we see in the map? Okay, it's pretty. It's so much prettier. It's loading. But look at that, the color. Okay, I think it's done for now. It will be done, so yeah. By the way, you can also do the same like what we did before in QGIS, like right click on the command and copy the Python path, a Python command. Here you can also do this, like go to this one, history. Okay, you click this one and you can just copy Python commands as well. Okay, that's it. And you will get these codes, and of course you will change this and input and output. That is important. We have error here. What's going on here? Okay, since we get this ref something, so yeah, it's very good approach. so then we don't need to repeat the process from the beginning. But let's see what's going on here. Oh no, it's 99 is we don't know what's going on, but let's go with this ref 1017. I think it's just empty. What's the name that we have the error for? I think it's after converted. Oh, 2018, bro. What we have problem is not 2017 but 2018 2009, because it's an empty. It is an empty. See, there is no reforestation there, or there is no forest gain, let's say. Okay, it said it's converted here, which means it's done with this 1000 thing. Let's go zoom to layer. Where is that located? Oh, there are so many layers we have. Let's group this. Let's make a group of this. Group. Let's call name YouTube example, or whatever name is. Is this any reforestation here? Yeah, okay. Ooh. Okay, it's okay. Okay. Or is what we're concerned now, we don't look at the forestations though. But let's see what is. Oh, we proceed. Six land. Oh, not land, bro. Huh? What is stupid? Oh my gosh. Forgot the index. Okay, so number 33. So we are going to for loop, but if e is more than equal to 3, and process again. But let's try. So we can ignore the error. Except whatever. Error in. Okay. Does it work? I don't know. Okay, error in. Why is error in there? Let's see. This is an empty. This is empty, empty, and empty. Okay, obviously it will give you error. It's not empty. Okay, it's done. We're done with this. So we can uncomment here again if you want to try again from the beginning. But this one is just to skip the previous process. So to print, texting print here is very important, so then we can trace back which one that is we have, which one problem in it, which one that we have problem in it. So you can skip it after, because it is a not asynchronous, but it is synchronous process. So it will run by one by one for loop iteration, let's say. Okay, That's all from converting JSON. Let's go back again to the result, and let's go with this. Okay, now we have this all of those land cover downloaded and extracted as per AOI that we need. We will look at this data first, and then we are going to use a package, what we call it as Pandas, later in the ArcGIS Pro as well. So we will analyze land cover and use land cover change in the data. So let's do that. So in order to analyze land cover, land use, land cover change, we can create a new notebooks here. I managed to create this, and then make it suitable with our case here. And then first we import the library that we are going to use, and again I will remind you that we need an absolute path, and then let's create a list of feature. So here we get the list of features in our time series GDB, which is in these files. Okay, so having creating the list, then we can see if it works. Print, or just display in the notebooks. You can uncomment if you want. And now we are going to use the regex pattern, which means that we are taking a pattern that start with the PL and underscore in this. So we are going to take only this list by importing first RE, or it means for regular expressions. Regular expressions means regex. So this one is the feature classes that is for land cover or PL in bahasa ya, penggunaan lahan, and it's following by the year as well. And first we need to intersect all the data into one files, so then these individuals layer will be merged into one single file, let's say. In order to do that, you can like directly use the geoprocessing here, search intersect, or again if you already know the Pythons, and you can copy path to here. You can start the analysis now. Okay. Okay, it's in process. All right. Here we put the intersect here, ArcPy analysis intersect as geoprocessing, and then in features it's like joining all the lists in here with the semicolon comma. So eventually it will be like this. More and more. And of course we also need to emphasize here that why this is important, because we put here as a workspace, so they will look at the workspace first and then listing the feature class based on the workspace here, or environment by workspace. Okay, here is done to intersect the data, and let's see what is the mess is happening here, because we just merge everything, or not merge, maybe like adding all the column, and spatially it will also make them as much as correlated each other. So from this one is only 2022, let's say, and we will have more. Yeah, you can see the differences, right? There's additional let's say polygon here, because this will have differences between, let's say, in 90s is this codes of land cover. We will see later what is this means. And we change with the let's see, change. So it's not changed yet. I think this one is mixed plantations, right? I think, I don't know, it's the same. Okay, let's see. And it become, yeah, this one 2014. From mixed dry plantations it changed into, I think, barren or settlement, I don't know. Let's see later in the following script after. Okay, now we done with the intersections, which mean that is overlaying all the land cover layers into a single feature class. That's called here from 90 to 2022 AOI. And next we are going to use the existing, that's why I use this in ArcPy or ArcGIS Pro with ArcPy, because we can directly look at this layer and, yeah, in the one interface UI. So that's what I like with ArcGIS Pro. Now we are assigning variables with this project first. Like previously, I think I made some video as well in the first sessions that we create a project. Current is the opening, the files that we are on, and list maps. And then let's take only on the map here and put a 0, which means that it's only single one map, and take it directly, not as a list. Put the object, and it's similar with this. We take the layers, but specifically with this layer name. And then let's see what is the field of its layer, and we take this as a wildcard PL. So this one is the list of PL, let's say. So we don't need to look every field in here, like shape, line, shape, luas, and so on. But we filter with this wildcard with a regex expression as well. And later on we will use that. Yeah, it's still hard coded though, because there is some changes that we need to do it manually here. Like air, I think, is like previous land cover in the data sets from ArcGIS server or from the server itself. So what I did now, just look at this and and copy paste into the dissolved field in here. So it will dissolve based on these fields only. So it will give you more a concise feature class at the end. Okay, let's dissolve this. And in the next, after we dissolve this, let's see, maybe the feature is 8,850, but now after we dissolve, it becomes 1,784. So it's more concise. The dissolve is also including making the feature into multi-polygon as well. Okay, so notice the differences here. We don't need to make this separate between here and here. I think this one is because of the boundary of the province, or yeah, province, I think. But we remove that and make it, yeah, basically dissolve to make it more concise, let's say. And next we will calculate the area in hectares in a new field. And in this new field, we are going to use the method of the geodesic. So it's not a projected in UTM, but it's the geodesic that is already there in ArcGIS Pro. I think ArcMap still doesn't have geodesic, but here in ArcGIS Pro it uses geodesic approach. Correct me if I'm wrong, but yeah, use geodesic instead to make it more simple at the moment. We're not discussing about the projection, so yeah, let's use this geodesic. Okay, so here is the result. We get the informations about the area here, but at some point also we have this very small numbers of the area hectares we need to cover. We need to take care of this later on to see if this is a mistake of the topology or not. Yeah, let's see later on. So let's close this first. Now what I'm trying to do right now is using different library, let's say. So what we use, the library that we use is Pandas here. So Pandas library is very ideal for the situations for data engineering, and also used for basically analysis data until visualizing the data, and also yeah, for data scientists I think they will know about this library, Python library. Okay, now we run again the process here. So we assign again this GDB workspace. Yeah, I think this one is from previous code and I managed to edit this. And first thing first, we need to set the workspace first, as usual. Use workspace is still the same in the time series. So, GDB. Oh yeah, geodatabase from ArcGIS. Okay, this one. So this one is the workspace now. And feature class here is the last feature class that we use here. Whatever naming here we can change if you change the data also in here. So basically you can just copy this and something like this, but yeah, this one basically. Okay, and then you need to create a list of field names. This way we will going to look at the fields names to know all the field names in here, and then after that we get the approach like using search cursor, and finally we have the data. So if you want to know about the data itself, it will be like this. Is something like an array, I think. Let's see, what is this? Or list. Yeah, and it will match with the field name. So this list like array, and then we have the columns field name here, list of the field names from the ArcPy list fields. Yeah, basically this one. We still store the information of shape, but I think this one is the centroid of the shape, so it's not actual shape of the data like in GeoJSON or like GeoPandas kind of thing, but this one is just a centroid, I think. Yeah, and then we need to reformatting the data frame. So I managed to search in online because I usually not copy this, but it will give you the unchanged indexing error. Just the warning, but yeah, to avoid the warning you can just copy this. And again we can use the regex, regular expressions here. I think at the previous analysis with the different data set we have this uppercase PL previously in different dataset of the land cover, but now we don't have. So basically we are fine only use PL though. Okay, but let's try this first, the column, and it will set as an integer, hopefully. So all of those column will set an integer, not the what is this, float or doubles. Yeah, and then we're going to drop this save line, save area, and because basically we have the area HA or hectare in geodesic. We don't need this part. Is this still, I think it's still in latitude longitude, so it doesn't mean anything at the moment. And then we are going to rename, so then we will have the same pattern of the field name, just to make it more consistent here. Like this one, it's not consistent, I want to make all of this similar as possible, consistent formatting. And let's see what is the result. So here is the result. So we have this now, the columns is good now. It's pretty. And now we're going to come to the part that we will take the data from Ministry of Environment and Forestry of the metadata, I think, data about the coding system in this particular land cover data. So we have the numbers like the codes 2001, 20141, and yeah, it's still comma here, I don't know. Yeah, and this one, and so on. So basically this number, it means something. Obviously it should mean something, and we can see in this, I think I put already here, or you can search as well in your let's say browser, and look at the codes of land cover codes from Ministry of Environment Forestry Indonesia, or Kementerian Lingkungan Hidup dan Kehutanan of land cover. So this one is the codes. This is CSV, guys. So first row is the column code. This is keterangan, which means that the labels in bahasa, and descriptions label in English, and description too. I think this one is more general descriptions. So this will be stored or not stored. It will be loaded in our Pandas object with reading the CSV. PD means Pandas because we imported here Pandas as PD. So we take that and read CSV of this location. Again, this location should be an absolute locations, should not relative location in this specific Jupyter Notebook. Anyway, that is the, we can read, run and read and run, and we will have the result. So yeah, this one, it's more it's easier and clearer than before, I think, in VS Code, because we have a kind of table like UI in these notebooks. You can see a description too is forested land. So we will have all these lands defined as forest, land cover defined as forest here. We have primary dryland forest, secondary swamp forest, mangrove as well. And we have dry shrub and wet shrub is degraded land. I think this one is referred to deforestation and degradations, but let's discuss this later. because in here, maybe in the following though, because in this following I classify myself. Yeah, this one is like personal analysis, it's not official. So I define the forested land that is deforested is from forested land change into others, whatever it is, maybe because becomes dry, mixed dry agriculture, bare ground, dry shrubs, it's deforestation. But degraded forest on the other hand is degrading the quality of forest, I would say, of the level of the forest from primary here to secondary. So in a sense that I think it's impossible if there is a case from dryland, primary dryland into secondary swamp forest, unless there is some mistake with the data itself, but that's not what I want to look at right now, because what we are going to look maybe at this point only on the deforestations. Okay, maybe you're familiar with the Google Sheet as well. Let's go maybe to compare the result later on. Can go with let's go with table to Excel. Or maybe you can use Excel though, or whatever, what you want, it's up to you basically. But let's go with this GitHub and move Y here. Okay, so let's run this and we'll come back again once data is ready in one side. Okay, so here is the process that we are going to handle, is to cleaning the data. First we need to check the columns, listing all the columns that start with PL, which mean again here. So we're going to check here. Okay, listing all the column, and we got this column, and then after that we will put a unique values of those columns, and we are going to list this unique value in this column. If there is some error, like the unique value say something 0 or beside of these codes, we will take this in this object, we will list them in this object, in this list list object. Okay, so let's try what it looks in these codes as the result. So print unique value for the columns, which mean here the columns. So basically it just doing a for loop of a dictionary items. So it gives you a key, and this is the values, obviously. Give you key, and then this the values. This all the value I meant. And the value is a row. I meant list. Okay. So this list give you the information of its unique value, so there is no problem here. It's aligned with the code, and if you tick down, yeah, we found this error. It's say it's 0 numbers. So if we go that way, you can also look at this PL column with 0, because our eyes sometimes is deceiving, like I said earlier. And we will see that the list that has problem is 15 and PL 17. and then we will take this error zero code checking the total area, small area. So it means that maybe we can remove that, disregard the we don't need to fix the small area, let's say, because what we are going to do is quantifications. But if it is a big area, then that means we need to do the topology corrections, which I think that's also not our concern. If we have a big area that has problem with topology error or some error in the data, I think we don't use the data instead, because it's a public data, not our data. But anyway, here we listing this data that has 0, we filter, and then after that we converting all this filter into a numeric for this area, so then we know the areas, because I think the format in here is like a scientific notations here with e exponent. I think that means that 0.001. So we need to use this to numeric, and we can get the list. We can convert it to list and sum this list. Okay, so the object of these areas finally will be summed into, and we will know the areas in hectares. It's not significant, it's too small, it's so small, so we can remove the list, this object based on the object IDs. So the object IDs that we want to remove is these numbers 40, 41. Let's do some cross-checking. So we go with that. So here is the object ID 40, 41, 42, 43, 45, and so on, and 46. Okay, so it's aligned, right? And the 1093. 93. Okay, so how many is this? Okay, it's only 8. Shape is from previous one without removing this 1784. Now it's became 1076. And now we convert again just to make sure it's numeric in this area here. We get numbers here. Now it's all the numbers, not an object values type. Okay, what we did also, I think, need to mention here, if there is some error, zero or error in the numbers, I think it won't have an error though, because the source is come from the database, right? But yeah, just if there's an error, then it will set to none. Okay, next we get this the area, the data frame already with a new shape, let's say, with these rows and these columns dimensions. And next we're going to look at the Unicode again, just to confirm all of those columns. And we have this set of the codes that we are going to use. So we have how many? I think 16, right? Just remember that. Oh, too much parentheses. Yeah, 16. I remember that. Okay, now we have 16 land cover codes here. From 22 and 23 we use only 16. Okay, in order to do some analysis, maybe let's do it in Google's Excel as well, just to compare. So we need to melt the data frame or restructuring into kind of a row type of the data, so we call it melting the data. And again, we put this at integer in the value, and let's see the unique value of this melt. And don't forget to just display this. Maybe display first. Okay, in the head. So the data, it become like this format, but the actual data here, it has the dimension of a lot, I meant. So there, it's restructuring the data from this type of column data into this format. So object ID is still here, and we get this area, but the variables, it's used its row. So if the area row is I meant in the object ID 1, variables is the column, and the value is 1001. Object ID 5, let's say, and it's still 90 though, so it will looks like the same, but in actual data it's not like that simple. So let's say here 1784, 50,000, and here is the same, and here 20. It's what numbers? See this ID and so on. So basically it's moved that into the row. So maybe I just show you a little bit now what we did earlier in the data frame or in Pandas. So maybe here we have the record of the same. What is the count? I need to count 40. Oh my gosh, sorry about that. 1785. We need to remove the 0. Data. And just remove this. Bye bye. I think 17, right? So remove this part, and now we clear. We're not filtering it again. I hope it's not scrambled, but I guess it's not. So we have the same count is 1667. Yeah. What is the column itself? 1667. Same. Yeah, same. 1667. Not 1776. Panic. Okay. Now we go with this pivot tables. If you are a visual people. So what we did is just to do like this. Filter ID and this forget a second ago. Area. Correct. What? What on earth? Come on. I need to change that first into an area of doubles or non-numeric. Let's go with the Google Sheet, guys. Can we just copy this directly? No idea. Boom, 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 boom. So what happened with the error here? But we cannot use Excel because the format is still in this scientific kind of numbers, so it has e exponents of, yeah, basically need to be divided by 10,000 here. So it doesn't work in Google Sheet, but let's see here. Is that, okay, it worked with Google Sheet, guys. Oh my gosh, thanks Google. Doesn't work with Microsoft. No need to buy Microsoft 365. Object ID row is here. Okay, and then let's go with the values area. Yeah, it seems same. And now we will take only let's say 90. Do not show totals, do not show total. Okay, so yeah, basically you copy this first and then copy and repeat the process with, let's say, 96 here. Oh my gosh. Yeah. Okay, yeah. So basically that's what it's called with melt. Is this different? Yeah, because we should put the variable here though in the column. Let's say this one is 90, and once we get the object ID coming back to number 1 again, so we should put the number the column with different label. Let's say in here, it's like, or to be precise, yeah, PL6. So you keep, why is that heading by itself? Okay, whatever. You repeat the process, and you can imagine if you have like 16 time series, it will take time in Google Sheet, right? So yeah, thankfully we have this approach in Pandas that's already covered by this melt TF. If you want to confirm again what I'm saying, that its object ID will repeat in specific variables, let's see. Let's say I go with this. Seems weird though. This format. Variable here. Let's say next I want to go with this PL. Yeah. Not or, maybe and. Dang. Okay. So we'll get this object ID again. So which means that you need to do it over and over again in Google Sheet. Just to remind you. So you keep copying here, and you can copy this first. Faster. Add another. This is just an example. I won't do it again. 96, 6, and then 1000. This is just an example again. Yeah, basically you keep repeating until it's finished 2022. So yeah, we have this where were we have this handled in Pandas for restructuring the data into more like a rows data type of data sets. So then we can track down the information of changes. Let's go the result after we this one from the previous. Let's go with another approach. After we go with this identifying structure, we can redo the pivot tables, or let's say doing the analysis again on this melt and then do pivot tables. So what I said redo the pivot tables is basically it means that from this to, let's say let's finish this bro. PL90 I guess, right? Yeah, and then let's add one row. This is just only example. Again, check ID. This one is code area and this one variable, let's say. And we do again the pivot tables from here. Why do we need to do this pivot tables again? Because what we are going to do in here, we do the pivot table so that we will know the aggregation sum of each let's say each land cover and the tag it changes. So first we have the values for the areas, the index variables, and the column is values. The aggregation function is sum. Basically in the pivot table it will be, because I didn't remember everything, values, variables, yeah, like this one, and the column is the code. Basically it should have column, right? Yeah, this one. So we'll have this kind of tables typed. So we will have more and more data until 2022 at the end, because we didn't put here manually. I don't like that, because one way also takes time to copy paste, and also there will always a mistake with the human error mistake. So that's why we need to code is to make this automatic as possible. So here the result, let's see if it has the similar result from not this one, let's close this one, bro. Okay, with these numbers. Oh, what are you doing? So this one is first numbers. Ow. Okay, see, it's the same numbers here, 1652, because it's 80, 1650, yes, meaning it changed into 2006 from 2002 maybe, but it's not spatial complicit for each areas, but this one is the summary of the changes in this AOI. So if you want to look at the changes in the graphs, we can see it later on, but this already confirmed the numbers. Where is that? This one. This, and I'm starting to be dizzy to look at this number. Dang. Yeah, and here, boom, here 2014, Boom. Okay, never mind. Minimize this. Okay, put it back again. All right, let's go again with these columns. The column is here. Why on earth we need this column? So we will create a graphs that will show you these columns, and then it's still hard coded though. We will put here. It can be non-hard coded, but let's see. Just to make this simple, just copy paste this and put here, and this values color will be here. It will list based on this code and look at this value color. So it's not like the other way around, not from value color to the list codes, but to list codes. Detect what is the codes in here in this previous codes list from the ministry here, and then after that you will see if it is in the list, and we will copy that again, take this approach categorical list, and then reset index and get the description meaning in English. It's not in Bahasa. So we get also the pair of this. Oh, we need to run, of course, obviously. And the cells, cells need to be run before take the variables printed. So yeah, this one is the pair of the codes. We will have the numbers of the specific data that is used in our AOI from the public data. We will have this land list codes 16, meaning that we use 16 code uniquely. And yeah, this one is, oh yeah, this one is to make it difference, maybe to make it to compare it. Previously we have 23, so we start with 0, so this one is 23 unique ID from ministry. And in the AOI we have 16 type of land cover that include also dry land, primary dry land forest from 90s, let's say, and until to swamp as well. Okay, swamp, it might be a pit land, but we don't also analyze pit land at the moment. So okay, so here we will plot a graph using a seaborn and use matplotlib, and let's see what is the result. Okay, it's loading. All right, here is the result, guys. You can see the changes here, right? It's look like the forest, the primary forest is decreasing but not significant. See? And also here we can see this some forest is converted to plantations forest at some point, and also to others, and it decreasing. And we can see the portions of this dry shrub as well. And yeah, one thing that is increasing here is mixed agriculture. So conversions in the OI, it confirms that it mostly converted, I think, based on this graph, to the mixed dry agriculture, which is a purple, right, or pink. Okay. And other is dry shrub as well. It's decreasing because it's used to conversion to agriculture. But that is the data saying, right? So that is if we want to look at all the data in all horizons of time. Okay, now we are continuing to know how much is deforested, because we already defined first, right? From the forested land to non-forested land, everything will be defined as deforested or deforestation. Degraded forest, on the other hand, is primary to secondary. Okay, I keep repeating it, but yeah. First, we do the renaming of the columns. So we will have the formatting later to be more specific, and we will get this integer as well eventually in the column, or in the in its value later on. So we'll get this confirmation of the time series data that we have 90s, and it jumped to 696 to 1000 to 2003 26 until 2022, and come back again to the df_2 just to see again. So basically the objective first is just to see the graph here to know the land cover, land use change trends in the areas to which land cover that is changing for. Like maybe I'd say it's to mix dry agriculture, let's say, it's on that graphs. But then here we do again and see the changing the renaming the columns first, but later on we need to define the deforestation based on the land cover type or land cover change basically. So here is the result coming back again to df_2 Pandas object, data frame object. We still have these anomalies, let's say, still in a float data type. Let's go make it as an integer. And again here I just want to remind you that we are assuming that in this area there is no pit lane, because in MRV, the first carbon greenhouse gas analysis emission or emission factor of the pit lane is deep in different calculations, so we don't cover in these videos at the moment. We will assume that everything is in the dry land. Okay, and then we will have these definitions of forested land in these codes. And 2006 plantation forests, based on the definitions of Ministry of Environment and Forestry, is categorized as a non-forest. Okay, so it's not deforestation if plantation forest is converted to mixed dry agriculture, let's say. So it's not plantation, it's not deforestation by these definitions. Only from natural forests converted, whether it's dry or swamp or mangrove, converted to other type of land cover, it will define as the deforestation. Okay, and then once we get this two lists, forested and non-forested land, we will create a functions that to define based on this let's say sequential time from a previous time series, let's say. So from 90s to 96, basically in these codes it say that create a new column that is let's say 96 deforested underscore deforested equal to if the forested land is in these values, and is in 96 is non-forested land. Okay, so basically it's keep looking for like this the approach, so it will repeating. So maybe there are some mistake. The mistake is if the rows has the error in the calculation or in some mistake of digitations. Let's say if in 96 there's a deforestation and then suddenly it become forest, let's say in 2000, and become deforestation again in here. So yeah, that's the case that it will repeated, it will count as repeated. But put aside that, I think we are assume that there is no mistake in this data first. So here is the implementations, what we do so far, and let's see what it looks like for the data itself. Yeah, like I said before, we will create combinations of this x1 means here if it is deforested. So if it is deforested, then it will say it as a true here. If it's not, then it will set a false. So nothing here is said deforested. But let's see here, 2021 is deforested, which means that in 2020 it's forest. So yeah, it's confirmed here from forest to non-forest. 2001 here is primary forest and 2007 is dry shrub. So from forest to dry shrub, it will define as deforestation. So here we have in the data. Now just for the future applications, because we are going to let's say apply this maybe in a peatland as well, but now we are assuming everything is a dry land, so we need to have a different column, say if it is dry land or peatland. But here we just assuming everything is dry land. There is a differences later in the carbon, not carbon, maybe I would say GHG, greenhouse gas emissions calculations, but here we use dry land. Now everything is in dry land. Okay, next we are going to melting the data again. And we will get this similar result. Yeah, you can imagine that if we use Google Sheet, it will take you like hours to do this approach, but since we are using this Pandas library in Python or in this notebook, so it just a second. So we have this shape dimensions 30,192 and 4 columns, 1 2 3 4. Okay, you can count to 4. All right, then here is the result of the numbers. Notice that we have the confirmation of the total areas here. Everything is the same, so there is no mistake. I hope, yeah, I assume there's no mistake here because we have these numbers. And what we have for the deforestation is in here 52,447 hectares deforested in this LOI of 2.3 million hectares, which means it's still yeah, 5%, let's say. Yeah, no, it's like 2%, man. But yeah, it's keeping yeah, it's accumulating though. But anyway, not about criticizing deforestation's definitions and the rate and all of those, but just to provide the information here based on personal analysis. I'd say it's not official. Again, this the This needs to be analyzed by some expert as well, and see also in the ground, verified, validated. Okay, enough with that. So here is the result. We get the result of the informations of the deforestation areas from 1996 until 2022. So if we have the data is from 90, let's say, this is not an annual deforestation for sure. I would say that maybe from the beginning, because first we have 90 the data set, and it jumped directly to 96, so it's accumulating until 96. And also there's a gap 4 year again here, and it's 3 year, and we have an annual deforestation here, which still big data here, but not from this one. I think maybe from 2012, because here we have 2 years. 2012 it's here, and it's increasing and decreasing, fluctuative, I'd say. Also needs to be verified again, this one, but yeah, I just want to make it more simpler instead of using Google Sheet, let's say. And here we have the index, and we have the index. What? Oh, why would I? We have the index, and now let's create graphs to look at to make the graphs that showing the fluctuations of the deforestations. So I still not preparing it, so I will take the time to code this. I use my old code, so I also don't remember myself. Bar 2 is not defined. Okay, we don't need this. All right, done. Okay, so here's tables that we can show to make it more visuals. And then how about maybe just showing the data from 2012 instead of showing everything here. So it's also a line that it should be from 2012, I think. So maybe can say, oh, why? Oh, okay. This. Yeah. Okay. All right. Okay. Hey, right. Yeah, 10 years ago. Let's go with this, that, and that, and that, and then goes to go. Yeah, it's more makes sense here. Later we can put some average here. Boom. And what is the annual average deforestation here? I can go with the make them as a list. And then of course plan. I just make this too complicated. Am I? Zoom. Sum. Not zoom, but sum. What? Not here. Mother. It's not here. It's this one. Okay, so that's the average deforestation from 2012 2002. Yeah. 16,000. Let's see again. Does it make sense? 16 is here. Yeah, it makes sense. We have a very big here. Big numbers here in 2018. Let's confirm 2018, guys. So maybe we can go with the formula, or not formula, with the this one. Let's do the query, bro. Wait. It is from 2018 deforestation, which means it's from 2017. Okay, I will check first the 2017. Here, properties, definition queries. We have here all queries. LID is equal to, yes, 1001, or ID equal to 2002. Maybe these two first, just to make it simple. And query just for a visual approach here. Okay, equal to 2001, or is equal to 2002. Just want to see differences. Okay, there are a lot. See the differences here. This number. Wait a second. Hey. Yeah. Here. See, it's easier to see, right? How big is this part? Short and mild metrics, bro. Kilometers. What hectare? Just give me hectare. Oh my gosh. Yeah, 1,000 here. Okay, so yeah, it makes sense. I think it makes sense, right? Cool. Let's continue, my friend. Once we get this result, let's say average of deforestations in this areas, and then we will look at this forest reference emission factor. If we go with these numbers, okay, it takes time, but yeah, this one is in the CSV already. So basically you just put it by yourself, the data from the documents into here. So it also has the informations of the regions. Let's say, oh yeah, this one, let's say tables. Come on, tables, give me real tables. Yeah, this one. So we can just take all of those data and then convert this into CSV, which is here. This is the CSV that we have. And now after that we have to import that again in absolute path. Then we can use this, and look, we have the Indonesia and Papua region of its emission factor. That previously here is based on the national forest inventory, and also applying some formula, allometric formula, and get this carbon stock so that become above ground biomass of its certain island coverage, or let's say region. And it has also the informations of the total ecosystem, which means AGB plus BGB. Oh, not this one, this one. I mean, this one is a standard error. This one is mean of the above ground biomass plus below ground biomass, and total ecosystem per hectares. So we get a per hectares area base. Now we get these columns as well, and then we have this, I mean, yeah, taking all this, just look at this column just to make sure it makes sense what type of this, and again examine the existing data that we have, because we are going to take the informations that is for Kalimantan region. Let's say here is already defined based on the region, but if we go to non-forest land cover class, let's say from the plantation forest, it's use the all island coverage of the emission factor, or let's say not emission factor, in this case is above ground biomass because it's not yet become TCO2, the ton carbon CO2. Yeah, I need to correct that from the beginning. Here it's not emission factor, it's above ground biomass, and total biomass, total ecosystem biomass. Later on we will convert that into emission factor, let's say. So here is the coverage of in Indonesia. Like say dry scrub, it has the AGB of 60, state crop is 48, settlement 2.17, and so on and so forth. And what we will to do here is convert that into a TCO2e, or ton carbon CO2 equivalent per hectare, and then we will create later on the field column named TCO2 per hectare. Here is the result. Now what we can do here, we will create the function again, just to know the what is the drivers, or maybe I would say what is the forest type that is deforested, because if the deforestation is from the primary forest, then the emission factor should take these numbers. But if it is from secondary dryland forest, then we use these numbers, and it will give you the emissions of all of those areas, not the gap between, let's say, if change from secondary dryland forest into shrub, we subtract these numbers, but not that way, but we emit all these TCO2 per hectares in totals. Now let's do it again to know what kind of the last LC or last forest cover. Yeah, this one, or maybe I'll say last forest cover. And then we will have these numbers of this new data frame. Type line is dryland, and we have this LC. What is 0 means in here? So it means that there is no deforestation in their areas like this one. But if we have that, then we need to check again. Let's say if the last we need to check if the area has 0 but deforestation happened twice, let's say. So first let's look at this. What is this offer? So yeah, it seems it works for now. Just look at what will happen later. Okay, so here the melting again of the deforestations like what we do previously, but now we include last land cover, which is saying that the last land cover is 1001, let's say. So the object ID and its variables in 1000, because it's like melting, right? So it's give you headache because here the actual data dimension is these numbers. So if we go with this object ID and let's say def, oh gosh, let's go again with this approach. Object ID number 3, right? 3 and variable equals to so it will give you false. But if you go with this 1022, which means in here it said that variables, it will give you true, because again it may appear it's an error, but it's not, because it keep repeating in the row below. So the actual index is 2006, 100642. Gosh, just too much. Okay, now we are going to use do the pivot tables again to just, I think, just repeating the process from the beginning, from earlier, I meant, not from the beginning. But we will have this none because there is no deforestation there actually, and we get this number to get the to fill in the none, to filter in, and it will give you 0 if it is none, and here is the final result. So to confirm, maybe let's do a quick information here. Let's say in 2022 the last forest cover is 2002, So I would say maybe from 1002 is numbers, then plus this number is equal to 30. Okay, and here above we have, oh my gosh, it's just too far. Okay, I will get back here below. Wait a second. Okay, this one, yeah, 1002 is exactly the same. So let's see with 2021. So the deforested forest before is primary forest here, but it's not significant numbers. And also these numbers, oh, you did it again. And these numbers, okay, so yeah, it's exactly the same. So if there is some mistake with these, like the numbers is not the same, then that something's wrong with the analysis, but they're all the same now. So again, why on earth we are going to use this, like splitting into this additional data here? So the reason of what we do right now here is because we are going to use these informations. Where is that? Yeah, these informations, an emission factor here. So we need to know how much is emitted or greenhouse gas emissions from the deforestations every year from 2022, let's say. Oh my gosh, this one is still it's still in deforested, not in year. So what we need to do is just simple put the year above, like what we did. Okay, this one, apply year. Okay, just simple, bro. Maybe I will put this. Okay, it's here. Okay, no worries, just okay, as long as it's here, we don't need to drop that. Okay, let's go again with the same approach. We are not interested with 2011 and above. Then we can go with this approach. Oh wait, okay, wait a second, my friend. Let's go with 3 is equal to dot copy. Oh, why the U is coming with me? Which means 2011, 12, right? Okay, okay, error. Because as type. Okay, it should copy from the beginning though, but it's okay. Right, it's from 2012. And what we can do right now is just to copy this and update the script. We'll merge, we will merge with the previous data emission factor, and we will have the data informations now of the emissions. So here is the result then, guys. So if we add these numbers based on the year, then we will have the additions number from this one and this one. But just to make comparisons before, from it's already there the numbers, but let's grouping based on total TCO2E. What? Variable plus LC and year maybe. Yeah. Doesn't make sense, bro. Year is in the front. Okay, and then what about the grouping? Oh, sorry, that what value, bro? Okay. So here is the total emissions. 8.8180 million TCO2 ton carbon. Need to verify this again. And in the MRV, I think based on the first deforestation rate within last year, within 10 years, we have the information of this one. This is the deforestation average 2012, but then emission average I think is always adding, right? So in the next we can avoidance. It's always tricky with avoidance though. In the avoidance you can say that maybe you will decrease the deforestation rate based on these numbers. So you will forecasting based on this as a baseline, but at some point as well you can say or justify the scenarios that the average deforestation year within 10 years, past 10 years, is actually 16,000 hectares. So if we use these numbers and then we forecasting the scenarios that we can justify as at a scenario at the future, then it will be always tricky. But I think maybe I should read more about the standard or methodology of the avoidance, but that's what it is. I think maybe we should stick with this number, the recent number in these specific areas, and also need to consider about the factor of the topography and what is the spatial data that's related with the deforestation. So I think it can be forecasted that deforestation pattern happening in certain areas. But yeah, that's it from the calculations of emission factor to the greenhouse gas emissions from deforestations. Particularly, we have these numbers here, and of course we can also have an average of this, but I think it's not about averaging because it's already gone, it's already emitted into the atmosphere. So one is emitted, then it's will be your baseline, I'd say, or it will be your carbon expenditure in the areas that we need to consider. And at the end of the day, we have these numbers, and we can subtract this number and have this emissions. So yeah, that's it. This one is not per hectares, this is in all hectares because we cover that. So maybe let's go and simple calculations here. Emissions will be must be something's wrong with the syntax again. It's always tricky with that syntax. Because yeah, maybe I just forget about the syntax. Release, then 0, boom. That's hectare, right? Number. Oh my god, it's just too long. This doesn't make sense anymore. Total deforestations 22%, 22. I don't know, mate. Let's go. Let's zoom. No, this one. Oh no. Listed and hectare. To list. Then sum this all. And boom. So average per hectare. Emissions. Big average per. Oh my gosh, does it make sense? Then it is okay. 495. It's almost like these numbers. All right, that's it. I don't know why would I have these numbers, but that's all. I think I need to print this. Print total. Not this one. Not this one. Not this one. Wait. I think this one. We already have. No, not yet. Print total prestations from to NLI is these hectares. You can read total emission here, right? But let's print again. CO2e. Okay, right, that's all. So yeah, thank you guys. So don't forget to comment if you have something in mind and some questions or inquiries about my videos. Please feel free to comment, and don't forget to like and subscribe. So thank you guys, see you again next time. Okay, just slow down. If you want to type it again by yourself, please do so. Okay, bye bye.